Yeah.
All right, so, well, good to know that, generally persons do push for it, because there are times, I kid you not, you don't feel like coming to class. I am not mad with you. You can take a little breeze out. Always remember that the class will be recorded. On that note, I just started the recording. So let's start and have a look at the skeletal system. All right, so I'll get the move on as regards to the class itself. So the skeletal system. Is the skeletal system important?
Very important, sir.
Yes,
We
sir, very.
need to
Yes,
stand up.
sir.
Yeah, what would happen if we didn't have a skeletal system?
We wouldn't have any structure.
Well, that's one,
No
we wouldn't have
support.
structure, no
We need a
support,
blood because remember, certain,
blood, right? So the hematopoietic stem cells, they are found in the bone marrow. So that is very important. So without it, we'd have issues with blood. What else? What about something relating to calcium? Bones have a good bit of calcium in them, right? And in terms of calcium regulation, right, we have to remember thyroid glands in terms of secretion of the parathyroid hormone. That is essential in terms of maintaining homeostatic balance of calcium in the blood. Do recall that in terms of muscle contraction, calcium is critical in terms of the muscle contraction which occurs in our bodies. So therefore, in terms of the repositories of calcium, that's in the bone, and then you have the osteoblasts, osteocytes, osteoclasts. They actually are cells which manipulate the concentration of calcium present in bones under the influence of parathyroid hormone, PTH. So that's very important as well, notwithstanding the fact of the structure, notwithstanding the fact of red blood cell manufacturing, as quite rightly pointed out, in terms of the bone marrow producing those red blood cells. We also have calcium maintenance, well, the homeostatic maintenance of calcium concentrations in the blood, calcium critical for muscle contractions as well. When we look at the skeleton, it can be divided into two sets or two arrangements. We looked last week. We have the axial skeleton, which is what? Somebody tell me, what are the components of the axial skeleton? That's from last day.
Vertebral rib cage.
Right, so it runs down the center. So that consists of, go ahead again, sorry, just say it again. I was over talking you, I apologize.
And I thought the vertebral.
The vertebral column, the skull,
and the
rib cage, right? Very good, right? So those things that run down the center of the body itself, that's the axial. Today we'll be looking at the appendicular. Those are the ones which are attached to our appendages, the arms and legs. So they consist of the two girdles. We have the pectoral and the pelvic girdle. The arm, the forearm, and the hand, that's what comes off of the pectoral girdle. And of course, sorry, the pectoral girdle, what comes off from the pelvic girdle, of course, will be your thigh, your leg, and your foot itself. So those are the important parts associated with those two. So the pectoral girdle, when we have a look at it, pectoral, what is the name of the muscle which you'll find right over, well, superior to the pectoral girdle itself? You find it right here on the chest. And sometimes with bodybuilders, with males, you see them dancing the pecs. I kind of give it away, right?
The pectoral muscle?
Yeah, the pectoral muscles. Those are the big ones here, right? So those are the muscles which are found on the chest, those pectoral muscles. And when you flex them, yeah, you can dance them, right? So here it is in terms of the pectoral girdle. You have the scapula, which is to the back, and the clavicle. What is the other name for the clavicle?
Collarbone.
Your collarbone. Yeah, your collarbone. All right. Anybody ever broke their clavicle? I could only imagine that's a special type of pain, and it will also render movement of the shoulder. It'll make it very tricky. All right. So clavicle, very important in terms of forming that joint, which allows for the movement of the humerus itself. When we look at the scapula, I don't know if anybody here from the Christian or more so the Catholic faith. Anybody know about a scapula? Some people wear it around their necks. Scapulas, both in the front and the back, is usually the image of a saint, and sometimes there's a prayer attached to it, right? And the reason why they call it scapula because of the shape itself. So some persons, they do wear scapulas, particularly of the Catholic faith, to the front and to the rear. In terms of the name scapula, I don't know, if I'm not mistaken, some other faiths also wear, prayers on like little medallions as well, but those are not called scapulas. So when we look at the scapula, we have the superior angle, the coracoid process, the acromion process. This is where you have the integration in terms of with other bones that come and allow free rotation, which occurs here. So when we're looking at the scapula, is shown here, it's very broad and it's more inferior, more located to the dorsal region of the human anatomy. This is showing again the scapula, and again notice it's wide and flat in shape, and this is because you do have attachment of muscles to the bone itself, and this big wide area shown here. The clavicle, or the collarbone, which we just mentioned, is shown here. The posterior of this is as the posterior surface, and then this is the extremities where you do have articulation with, in turn, either the vertebral side or the shoulder side of the skeleton itself. So this is showing the articulations of the clavicle. So here is the clavicle. Here's the acromioclavicular joint formed between the acromion and the clavicle itself. Here, of course, this bone is the humerus, and the top of the bone is the head of the humerus. So notice the shape of the of this particular joint, and the reason why it's shaped like that is to accommodate the head of the humerus. So this, of course, is showing the humerus on the skeleton. Note the location of the humerus, and the humerus is a long bone, and the head consists of the greater tubercle, lesser tubercle, and the intertubicular groove as shown here. So these, of course, articulate at the shoulder joint. From the humerus, you have now the ulna and the radius itself. Ulna and the radius, these are bones of the forearm, and they articulate with the hand. Ulna and radius, which one actually articulates with your thumb? So if you move your hand left and right, which one always follows the thumb? Is it the ulna or the radius?
The radius?
Yeah, well done. Yeah, well done. Yeah, the radius always follows the hand, if you notice, in terms of the movement. And the reason why it follows it, sorry, not the reason why, a nice way to remember it, particularly for persons who are double jointed, if you put up your thumb, like, in a thumbs up, it kind of looks like the letter R. If you look at the shape, well, okay, and if you turn it with the palm down, with your palm facing downwards, and you're coming up from your forearm, and then your thumb goes out, it looks like a common R. Yes, no, maybe. Okay, that's how I remember it anyhow. But just take note, the thumb always articulates with the ulna. So regardless of how the hand moves, that's how you could find the ulna from the thumb. Just go straight down, run your finger along your thumb and let it continue along your forearm, and that bone it touches, that's your ulna. So here it is, the ulna, showing both the ulna and the radius. So this is the ulna shown here, and this one, of course, by method of elimination, is the radius. So you have two bones. Why do you think you have two bones and not just one? Why do you think? Why two? Imagine you, okay, I'm not saying you're God or anything like that, so please don't bring your pastor for me next week, your pastor, your pundit, or your imam, or your priest. Don't bring him or her for me next week. But imagine you had the ability to create something, right? And you're looking at the forearm, something like a hand. Why would you put two bones as opposed to one?
Would it be for support, sir?
For support and movement, you could get a lot more movement, because remember, with the thumb is unique in terms of its motions. Yeah, you have a lot of motion. So to increase that motion or movement, yeah, you'd want a freely moving bone to articulate with it, right? So that's right in terms of the radial articulation. So that's one. Anything else? Why would you want two as opposed to one? Imagine like one thick bone. So all here, imagine full up with bone. So what's the difference? Where you don't have any bone here, to the middle, as opposed to just having like 2 strips of bone. Some begins with W. And it rhymes with gate.
Can I have a vowel, please?
Wait.
Thank you, weight. That's right. So weight. So to keep the weight down, and you see that repeated in the body, Maybe if it was solid bone, think about it, the arms might be at the side all the time. And seeing that we use our arms so much, initially we did, in terms of if you were to follow the evolutionary process, we did walk on, all fours, but then we moved from that to a standing position, right? So maybe in so doing, right, we didn't need so much pressure to be placed on the bones itself, so they thinned out. And again, another useful thing for that is weight. You do keep the weight down as well, so you're able now to move the arms that much more freely. Oh, no, somebody jumped in front of you before I could tell you a vowel, so that wasn't needed in that case. Let's have a look at the hand. The hand consists of the phalanges, metacarpals, and carpals. Notice these bones here. Out of all of these sets of bones, which ones do you think will be the most difficult to heal if you get a fracture? Would it be the carpals, metacarpals, or phalanges? Which one do you think will be the most difficult and why? Carpals, metacarpals.
Carpal? Oh.
Okay, you're correct. Carpals. Why do you think carpals will be the most difficult to heal?
So
Because they're the interlock, they look like they close together.
Yeah. They're close, they interlock, they're small, they're chunky, right? So it's tricky, it's very tricky. So do remember, if you're looking to fall, always try to show your shoulder in. We have anybody here who were goalkeepers or who played cricket in school? Wicketkeeper?
Yeah.
Yes,
Yeah.
sir.
Right. What you're saying? So you were taught how to fall, right? Most critically. Or I don't know if anybody for other sports, they teach you how to fall, anybody was wrestling or things like that. When you're falling down, what is the first thing, where do you throw your weight? If let's say from a
shoulder.
yeah, oh, what you're saying? Okay, it don't make sense. I don't know everything. Well done. Yeah. You always throw your weight on your shoulder. So when you're falling down, you throw your shoulder and then you roll. Right? Excellent. What sport you played or play?
Answer, but
Huh?
as watch football.
Oh yes, watch football. Yeah. So if you watch a goalkeeper in particular, you'll see when he catches the ball, they put the ball, they try to get the ball down. If they hold it, they get the ball down on the ground, then you see the elbow go down, but the shoulder takes the weight of the body and then they roll. From the time the shoulder hits, they'll just roll, the goalkeeper will roll. Right? And that's how you do it. If you do it otherwise, you could damage yourself and you could break some bones in the process. So it's something that you learn. If you watch wicket keepers as well, they do the same thing. When they go for a far out ball, you see them dive, they'll snap up the ball, in the glove, and then they throw in their shoulder. So that was very good observation. You can make a very good scientist because that's what scientists are. They're not necessarily good looking, but they are good lookers. Of course, you might be the exception. We know that, but always remember our art teacher telling me that, artists are not necessarily good looking, but they are good lookers, which means they scrutinize things very deeply. So the hand, these bones, tricky ones, the carpals, they're very difficult to heal because of the fact they're so small. And sometimes what they have to do, if you do get a fracture, they have to pin it. You have to pin them in place, right, to actually aid in the healing process. So that is something to think about in terms of always be careful with your hand. All right. So now we're moving to the girdles, your pelvic girdle. Right? And the pelvic girdle, here it is, very important because this supports the weight of your body. This is why it's also critical when you think of your pelvis, not to play musical chairs with granny, right? Or an older member of the family, musical chairs, and you pull away the chair and granny look to sit down in the air. Next thing, granny fractures or grandpa fractures his or her hip. Right? The reason why it's difficult for this to heal, one, of course, in advanced years, calcium homeostatic balance is out of whack, but also this bone is like a pivot. If you think about it, your pelvis, your legs articulate from your pelvis and your upper torso as well. It pivots from the pelvis. So this bone is critical. If it is broken, it's very difficult for it to heal, particularly for older persons. I don't know if anybody could relate to that if they had an older member of their family who got the pelvis fractured, the hip, somebody had a hip fracture. And sometimes, depending on the age, that could lead to a cascade of things, which unfortunately ends up in death, over a period of time, because infection sets in, it doesn't heal, and mobility goes down, and, a whole host of things happen. I don't know if anybody could relate to that.
Yes, sir.
Stacy, yeah.
I've not seen it. I've
Mhm.
not had it with any personal members, but I
Mhm.
see what hip fractures can do. Oh,
Right.
that do pelvic fractures, yeah.
Particularly for older persons, it gets, to heal it is very, very difficult. And sometimes they have to, you need surgical intervention where they have to put in steel, because the bone doesn't heal at all. It gets very, very tricky. So just to take home message, don't play musical chairs with granny, all right, or grandpa. Always remember that. We don't want them to get
Sir,
a
I have a
fracture of the hip.
question.
Go ahead.
Is it true that after you reach a certain age, your body stops absorbing calcium?
Not to my knowledge, no. And I find that, to the best of my recollection, I would say no. Maybe it decreases. That I would agree. As you get older, in terms of metabolism, and also your metabolic rate goes down, which is why, you see older persons, they're not running around, jumping up and down and all of that. So the amount of energy that they need to burn, quote unquote, that goes down. So by extension, the amount of things that they need goes down as well. So I could see where calcium, in terms of calcium uptake, will be decreased. But does it stop altogether? Not from my recollection, no. It doesn't stop altogether. Because if it
That
did,
is-
go ahead. Mhm.
That is what they taught us long ago. But if you look at the articles and things, it's
Mhm.
not like that anymore.
Yeah.
Yeah.
Another thing in science, which is one thing I've learned over the years, is that absolutes, you don't speak, absolutes don't really exist. You say then that it decreases significantly. So maybe the absorption of calcium decreases significantly as you get older. I could agree with that. But they say it stops altogether. That would be a little tricky, because then you have to ask yourself, then if it stops altogether, how it is somebody over 100, how do they have muscle contraction, on a consistent basis? Notwithstanding the fact that they are taking it in from their diet, but how it is then that they're able to move, to talk. Just movement of the head and so on involves muscle contraction and also calcium. So I would agree with the statement, yes, that as you get older, calcium absorption and metabolism decreases because you have lesser movement. But to say then that it stops altogether, I would tend to disagree with that statement. Okay, that's okay. Or that it stops altogether.
Yes, sir.
Yeah, okay, great. Let's have a look at the pelvic girdle. So here it is, we're seeing, of course, the vertebral column runs down here. This is showing then the sacral joint. This is the sacrum. This is your coccyx, and we'll see in just a little while, in the next slide, the difference between male and female as it relates to the coccyx as well. So these are the different points. The acetabulum, this, of course, this articulates with your femur, the femur joint, right? The ischium and the subpubic angle. This is this particular angle. We'll see the importance of this in the next slide as well. So this is just showing the parts of the pelvis, and we have to take note that the pelvis is very important in terms of supporting the weight of the body itself. When we're looking at the male and female pelvis, let's see if we can notice some differences. One, what differences could, well, they're stated here. So here we are looking at this pubic angle, right? And this is a male, it's more acute, and in the female, it's wider. Now, why is it that the female pelvis is spread wider? One word.
Childbirth.
Childbirth, yeah,
Childbirth.
Well, okay, I'll give you the hyphenation in terms of childbirth. Yeah. So for the delivery process and for supporting that weight. Remember, in terms of supporting the distended abdomen, which occurs during childbirth. Sorry, not childbirth, but during pregnancy, there's more weight. So that's why you have the flaring of the hips, right? And that's why women in general tend to have wider hips than men. Okay. But it's all of these modifications primarily for childbearing. Quite right. The bone thickness is heavier in the female than in the male. The acetabulum is larger. This is it here, and more closed. And we mentioned the pubic angle, right? It is more acute in males versus being spread out in the female. So the coccyx, note the coccyx here, which is like this part here. In the male, it's more curved, and in the female, it's straighter. Why do you think so? So this is a female. Why would you not want the coccyx to be curved in a female? One word.
Childbirth.
Okay, I'll give you, in terms of the explanation, I'll give you 5. So why do you need for it to be straighter? Yes, childbirth. Delivery. What other danger you could have if it's curved? Remember, this is taking it, this is it in the back here. So this is running with your spine. So this is your spinal cord. So this is towards your back, right? The bottom part. Why it is you don't want it to be curved?
Because you don't want the weight of the baby to put pressure on that.
What could happen? Yeah, what could happen if the baby push up against this? What could happen?
To get damaged.
Yeah. So you could be looking at brain damage or something like that. You could be looking at rupturing of the leading to leakage of amniotic fluid. You know, if you have the piercing of the amniotic sac, right? You could have that happening. So to get around that, the body, you know, it's straight. Right? The coccyx is straight in women, or straighter, a lot straighter than in males. All right, the femur. This is the hardest bone in the body. If it is, let's say you're looking, if we had some people who want to fight, and I don't condone fighting or violence or anything like that, but if you're, let's say you're in a, you're running a lab and you see a skeleton, which bone you'd want to grab is this one, the femur. So the femur, it's inferior to the, it's superior to your knee and inferior to the pelvis itself. Your femur bone, it's the hardest bone in the body itself. Why do you think it's the hardest in terms of density? Why does it have to be so hard? One word. Because it has to support. Yeah, support what?
The whole upper body?
Yeah, the weight of the body. Yeah, quite right. It has to support it, notwithstanding the pelvis. But when you stand up, if you think about it, yeah, that femur takes the weight of the body. So that's why, do remember, if you do get in a fight, there's the one you want to grab. The femur, there's the one. It's the hardest bone in the body because of the fact it has to be hard, because it's in terms of density, because it supports all that weight. When we look at it in terms of the structure, you have the shaft, you have the epicondyle, the medial epicondyle shown here, and the lateral. This is where articulation occurs. So articulation with both, well, the patella comes here, and then you have your other bones associated with your lower leg. What's the 2 other bones associated, which are like parallel to the ulna and radius? What are those? Which are the other 2? T and F. One is your shin bone, and one is the one behind the shin bone. The shin bone, tibia is your shin bone, and the other one is your
Fibula.
fibula. Very good, yeah. So notice it's parallel. When you look at the tibia and the fibula, it's parallel to the radius and the ulna itself. Here we are looking at the patella. Patella, also known as your kneecap, right, or your knee. Very important. What would happen if that shatters? You know, if your kneecap was to shatter, what do you think will happen? Would you be able to have flexion of your knee?
No, sir.
And the answer is no. You wouldn't be able to. You wouldn't be able to walk. Your walking will be very tricky. You know, so do keep your knees in order, your kneecaps. All right, the patella, very important for that. Here is your tibia and your fibula, as we mentioned, the shin bone, and you have these condyles and these grooves, and these are necessary for articulation with the supporting bone. On this end is for the femur, and down here, of course, is with the lower foot itself. So this is the shaft of the tibia, and the fibula goes behind it. And you have these grooves which allow for 2 things. 1, for articulation of the bones or movement of the bone, and 2, attachment. They also serve as attachment points for muscles, right? So you do have muscle attachment points on these bones itself. Now we reach the last part, the foot. And when we look at the foot, we have the tarsals, metatarsals, and the phalanges, right? Phalanges. These are your toes themselves. Metatarsals and the tarsals, which allow flexion when it articulates with the bones that we just mentioned, the tibia and the fibula. What is this bone behind here called?
Calcaneus.
It don't make sense. It don't make sense. I teach, you all know everything. Well done. This is the calcaneus, right? So anybody ever try going into a soup shop and say, hello, can I have a bowl of cow calcaneus soup? And they're watching you funny and they say, what you mean? And you're laughing, kya, kya, kya. I mean a bowl of cow heel. You don't know cow heel, it's calcaneus. Kya, kya, kya. Anybody ever try that?
No, sir.
No, and
No,
I wouldn't
sir.
suggest you do it because they'll probably spit in your food. So always make that joke after you have the cow heel, right? But don't make it before, because there's a probability they wouldn't take too kindly to it. Just like how when you go into certain restaurants and ask them if they have MSG, it's not a good thing. It's good to make that joke when you're coming out, yeah? Always remember that. So here it is, the calcaneus. And in terms of articulation, it articulates with which muscle that is here, also known as the calf muscle. It's a long name, but how I often remember it, I think about the NP vehicles that bring gasoline to the station. What do you call that? A simple name. It's a gas what? What type of vehicle is it?
Truck.
A truck.
That's the truck.
So this the muscle here is therefore the gastrocnemius muscle. Yeah, that's how I remember it, because there's the one we always walking around, right? So a calf muscle, very important. And how I remember it is like the NP station, a gastroc. Well, that's the first part, and I'm showing the emius. So the gastrocnemius muscle via the Achilles tendon, it attaches to your calcaneus bone here and allows that movement, you know, flexion of the foot. That's why if you do have the Achilles tendon is cut, you don't have movement because you just don't have any. While this is a pivot point, you no longer have the contractive force necessary, which comes from the gastrocnemius muscle. So do remember those muscles, this muscle in particular, the gastrocnemius, via the Achilles tendon, attaches to the calcaneus bone, which is down here. Right, and then we have these bones, the phalanges, metatarsals, and the tarsals. Okay. Any questions?
Sir,
Yes, go ahead.
it's about the recordings, like the one from last week. I was looking for it, but I'm not seeing it. Is it on the e-classroom?
Okay, let's have a look. See.
When you click
1
the
minute.
Zoom link from last week, the recordings come up. I just discovered that today. I don't know if it's so for
Okay.
everyone.